As we get further into circuits, the circuits are going to start to get more and more complicated. And the way to handle that is through a problem-solving strategy called Vir charts. So I'm going to show you today how to use a Vir chart to solve for everything in a kind of complicated circuit. So some circuits might ask you for, let's say, the resistance or the current across the 5 ohm resistor. It looks like my computer dropped my omegas. And maybe, in this one it's kind of easy, but maybe you are not able to immediately see it because there's some other resistor influencing it. So we're going to use Vir charts to figure out everything about a circuit so that we can then answer questions. So sometimes if you're not clear on what the steps are to get to an answer, you start filling out a Vir chart. It's kind of the universal problem-solving strategy for figuring out circuits. And that should feel nice because we haven't had a lot of universal strategies that always work. And a Vir chart is one that will pretty much always work. So to make a Vir chart, I basically need a row for every part of the circuit. So on this circuit, we'll have, let's say this is resistor 1, resistor 2, and resistor 3. So we'll have resistor 1, resistor 2, resistor 3, and the battery. Okay. And then each of these will have a V, an I, and an R. And that's what makes it a Vir chart. So we will find the voltage, current, and resistance for everything in the circuit. Let's get started. First, let's fill in what we know. The battery is 3 volts, so I will fill in 3 volts for my voltage on the battery. The resistors are 8 ohms, 5 ohms, and 2 ohms. And then for the battery, the resistance is going to be the equivalent resistance. So if I were to find the equivalent resistance for this circuit, Req inverted is 1 over R1 plus 1 over R2 plus 1 over R3. So I'm going to use the calculator to speed this along. I add up the inverses of those resistors and then take the inverse. So I'll do 1 over 8 ohms plus 1 over 5 ohms plus 1 over 2 ohms equals 1 over Req. So after I add all those fractions together, I then have to flip my answer. If I do that, I get the equivalent resistance is about 1.21 ohms, which makes sense. Remember, it has to be less than any of them since this is a parallel circuit. Well, now I can easily find out the current from the battery because voltage equals IR. So if I divide voltage by resistance, that will give me current, 3 volts divided by 1.21 ohms, and I get 2.5 amps. Now, I also notice, since this is a parallel circuit, all the resistors should get the same voltage from the battery. Simple parallel circuit, 3 volts, 3 volts, 3 volts. Oh, and now I just divide each of the voltages by the resistance. So 3 over 8, I've got 0.4 amps. I'm just rounding here. 3 divided by 5, I've got 0.6 amps. And 3 divided by 2, 1.5 amps. And if I've done that perfectly, those will all add up to my battery amperage, because remember, whatever leaves the battery is eventually going to come back to it, even though it splits across each resistor. And that's my completed Vir chart. Now I can answer any question I want about that circuit. Now let's try this circuit with a 3 ohm, 4 ohm, and 5 ohm all in series. So in this Vir chart, I will have, say, resistor 1, resistor 2, resistor 3, and the battery. R1, R2, R3, and battery. They do not always just have to have 3 resistors. It's how many ever are in the circuit. And we will have a V, an I, and an R. Okay. So things I can fill in first. The voltage on the voltage on the battery is 9 volts. And my resistors are 3 ohms, 4 ohms, and 5 ohms. My equivalent resistance, since this is a series circuit, I just add those up, so 12 ohms. Meaning the current from the battery is 9 divided by 12, or 0.75 amps. And since this is a series circuit, remember from yesterday, current is the same everywhere in a series circuit, 0.75 amps, 0.75 amps, 0.75 amps. And to get voltage, then, I just multiply, because V equals IR. V equals IR. 3 times 0.75, and I get 2.25 volts. 4 times 0.75, and I get 3 volts. 5 times 0.75, and I get 3.75 volts. And if you add all this together, you get 9 volts, because the total voltage has to add up to whatever total voltage is on the battery in a series circuit. If you're confused there, flip back to your notes from yesterday and read the rules again about parallel and series circuits, because that's what I just used to figure that out. And our final one, so here's one where I show you examples of questions that wouldn't be so easy to answer without a VIR chart. So I'm going to make the chart first, and I notice this is a combination circuit. There's some series here, and there's some parallel here. So I'm going to have to play around with this one to figure out what's going on. Okay, so first let's label everything. I'm going to call this R1, R2, R3, R4. Okay, so I've got R1, R2, R3, R4, and the battery. And each will have a V, an I, and an R. Okay. Boop, boop, boop. Making my chart. Okay. Well, the battery is a 14-volt battery. R1 is 5 ohms. Notice my ohms got messed up again. R2 is 6 ohms. R3 is 1 ohm. R4 is 2 ohms. Now, I can't just figure out the equivalent resistance right there. That's a little bit more difficult. Whenever I have a circuit like this and I'm trying to figure out equivalent resistance, I look for things that are clear. For example, it is clear to me that R1 and R2 are in series with each other. Any current that comes through R1 will have to go through R2. So I'm going to put those two together, and let me show you what I mean by this. I'll basically redraw the circuit as I figure things out. So I've got my battery, and I've got the 5 ohm resistor, and the 6 ohm resistor. And now I'm saying that R3 and R4 are in series, so together they are equivalent to or the same as a 3 ohm resistor. Take a second to convince yourself that that's right. If these two are in series, their equivalent resistance must be 3 ohms. So I could actually take those two out, replace them with a 3 ohm resistor, and it would be the same thing. So this is my new circuit. Well, now I notice that the 3 ohm resistor, the one that I've replaced those two with, and the 6 ohm are in parallel. So these two could be replaced with a 1 over 6 plus 1 over 3. Take the inverse. These two together could be replaced with a 2 ohm resistor. So these two together are the same as a 2 ohm resistor. Again, take a second to convince yourself that that's right. These two are in parallel. Their equivalent resistance is 2 ohms. And so the circuit would not change if I took them out and replaced them with a 2 ohm resistor. Now I'm left with a 5 ohm and a 2 ohm that are in series with each other, because anything that goes through this 5 has to go through both the 6 and 3, so it would have to go through the 2 ohm that I replace it with. That means that my equivalent resistance for this circuit is 7 ohms. Okay, so 7 ohms across the battery, making my current 14 divided by 7, or 2 amps. Now, I once again have to stop and think. 2 amps go through the 5 ohm resistor for sure, because whatever leaves the battery must pass through that one. There's no other way it can go. So 2 amps on the 5 ohm resistor, making its voltage 10 volts, V equals IR. And now current is going to split between the 6 ohm and the 2 down here. But the voltage must be the same because now these are in parallel, so they'll get the same voltage. If we had a 10 volt drop across the 5, we've got 4 volts left over. And so each of these wires will get 2 of those volts because, sorry, not 2. We'll get 4 volts because now that we've gone across that 5 ohm resistor, there's 4 volts left over. So it's kind of like there's a 4 volt battery right here, 4 volts left over. So these are both independently connected to the 4 volts, meaning that R2 with its 6 ohms will get 4 volts. And then the voltage, though, will in some way get split across these, so we'll have to figure out what happens there. We can, however, very easily figure out the current on the 6 ohm resistor, because we've got all its information. And that would just be 4 volts divided by 6 ohms. Gives me 0.7 amps. Now think about this. The current splits here, and we now know that 0.7 amps go through the 6 ohm resistor. So the rest must go through the bottom part of this. And neither of these two can use up current, so they will both get the rest of that 2 amps of current. 1.3 amps, 1.3 amps. And now I can easily figure out their voltage. 1 ohm times 1.3 is 1.3 volts. 2 ohms times 1.3 is 2.6 volts. And together, those two should add up to about 4. I've done some rounding, so it's not perfect. But those two would add up to 4 because, remember, this part of the circuit we said is basically connected to a 4 volt battery since 10 volts dropped across the 5 ohm resistor. This one, very complicated. We're about 6 minutes into this, so you may want to rewind the video 6 minutes and watch that again. But now, I can find any of these things. A, find the current through the 5 ohm resistor. Okay, well here's my 5 ohm resistor, current is 2 amps, 2 amps. Find the voltage drop across the 6 ohm resistor. Here's my 6 ohms, 4 volts, 4 volts. Find the current through the 2 ohm resistor. Here's my 2 ohms, current 1.3 amps. We're done. I highly recommend you try the extra practice on this, creating a Vir charts for about 9 kind of simple circuits. Highly recommend that practice before tomorrow.